October 7, 2025. The European Space Agency finally dropped the first official images of interstellar visitor 3I/Atlas sweeping past Mars. Anticipation was sky high, but instead of awe, what followed was outrage. A blurry dot, no detail, no color, and a deafening silence from NASA, China, and the UAE. The very agencies expected to reveal history. The question spread like wildfire. How could the most watched flyby in years deliver so little? And what exactly were space agencies not telling us? Within minutes, the so-called official image was everywhere, reposted by science pages, space enthusiasts, and meme accounts alike. The frame showed almost nothing. Just a faint, fuzzy glow barely above the background noise. By noon, ESA was trending, not for discovery, but disappointment. Hashtags like #FuzzyDot and #WhereAreThePics took over X and Reddit, where users dissected every pixel. Soon, comparison posts flooded in. Backyard astronomers using modest telescopes appeared to capture clearer results than a billion-euro orbiter. Critics accused ESA of hiding data, especially with other space agencies remaining silent. Every unanswered question only deepened suspicion. But behind the noise was a simple, frustrating truth. Physics. The CASIS camera aboard ESA's ExoMars Trace Gas Orbiter was never designed to chase interstellar comets. Its mission is to photograph the Martian surface, landslides, dunes, frost. When it turned toward 3I/Atlas 30 million kilometers away, its design became its limit. Each pixel on CASIS covered roughly 340 kilometers at that distance, enough to swallow entire volcanoes, let alone a comet nucleus, only a few dozen kilometers wide. No matter how long the exposure, the target was simply too small to resolve. Nick Thomas, the principal investigator, admitted, "We pushed it as far as we could. Just detecting it was a stretch." The resulting image, that infamous fuzzy dot, wasn't a cover-up. It was a technical ceiling. The gas coma surrounding the comet, thousands of kilometers wide, blended into the Martian background. The nucleus itself disappeared in the blur. The public wanted a portrait. The camera could only provide a fingerprint. Attention then turned to NASA's HiRISE, the high-resolution eye aboard the Mars Reconnaissance Orbiter, famous for spotting rover tracks from orbit. If any instrument could reveal detail, it was this one. But when the comet made its closest pass, HiRISE went dark. A U.S. government shutdown, which began on October 1st, froze operations. No uplinks, no data, no updates. The entire mission went silent. Even the pre-planned imaging schedules, normally public, vanished. As NASA's data feed stalled, people turned to China's Tianwen-1 and the UAE's Hope orbiter. Both had tracked the comet. Neither released a single frame or comment. The collective silence fueled one conclusion, that something bigger was being withheld. In this vacuum, the internet filled the gaps. Amateur astronomers from around the world started sharing their own observations. Some stacked dozens of exposures, others used AI filters promising to reveal hidden structure. Melbourne-based comet hunter Maya Trin led the first group. Posting enhanced frames she said revealed non-random streaks around the core. Her posts went viral while professionals countered with simulations showing how stacking faint images can create false patterns. Experts explain AI sharpening can make artifacts look like features. It improves style, not science. Soon, forums were filled with technical debates, deconvolution, signal-to-noise ratios, pareidolia. The deeper the discussion went, the blurrier the truth became. Then came a twist from the surface of Mars itself. Mallory Lefferland, a shift lead on NASA's Perseverance rover, authorized a special sky tracking sequence. 10 minutes of continuous navcam exposures aimed at catching 3I/Atlas as it passed. What she captured shocked everyone. A faint streak across the Martian sky. At first glance, it looked like a sensor glitch, but the timing matched the comet's trajectory perfectly. At 90 kilometers per second, Atlas would cover roughly 54,000 kilometers in 10 minutes, exactly the streak's length. The math lined up beautifully, but without access to the original exposure data, skeptics argued it could also be something much closer, even debris in Mars orbit. Still, that single faint line became the first quantifiable clue amid a sea of speculation. Adding more intrigue, the comet's apparent trajectory pointed near the same patch of sky associated with the legendary 1977 WOW signal, a 72-second radio burst that has never been explained. Now, with 3I/Atlas passing just a few degrees from that coordinate, the coincidence was too eerie to ignore. Online forums exploded with speculation. If a signal of that strength originated near the comet's path, it would have required gigawatts of power. Yet, once again, no observatory released hydrogen-line data, no listening campaign, no confirmation, just silence, optical and radio alike. Then, on October the 29th, 3i/Atlas disappeared behind the sun. For nearly 2 days, it became invisible to all Earth-based telescopes. During this blackout, every theory thrived. Some predicted natural fragmentation, others whispered about a maneuver. The Galileo project, which studies possible non-natural space phenomena, announced a 24-hour watch, hoping to catch any anomaly as the comet rounded the sun. When Atlas reemerges, astronomers will scrutinize its brightness and orbit, looking for any deviation, any sudden dimming or breakup. Each data point will either confirm a natural origin or open new mysteries. In the meantime, ESA's blurry dot, NASA's silence, and rumors of missing data remain the core of the mystery. Every delay, every unexplained gap, keeps the public guessing and the story alive. Because sometimes in space exploration, what we don't see speaks louder than what we do.